So hello guys, this my name is Aryan and I'm recording my assignment for machine learning subject. So this is let's start doing it. So first of all, I have to I have to upload the iris.csv file to my Google Drive. So I'm linking here my Google Drive to my Colab notebook. So this is the method we can use this like this in built library here. Like this will help to like import drive, and this is mounted, and now we found the library path. So the path of where iris.csv file is this, and we saved it as a file name. As a file name is a variable which saved inside. So now we're gonna import a library pandas to read the CSV file. So iris is and it's reading here. So now we're printing the iris. So this is the iris file, and it's 150 rows and 5 columns in it. So the first one is going to show the first 5 rows. We can show the iris.head file, or we can just, we don't have to write iris.head file. It will show first 5 always. It's like that. So showing first 5, and now we have to do is we have to change setosa to 0 and versicolor, because like that will be easy for data to check rather than checking the word. Like, easy to calibrate for like machine learning and for learning purposes. So we're changing it to numbers. So setosa 0, versicolor will be 1, and Virginia will be 2. So it's staying inside this variable. Now we have to map through that. So what we are mapping, what we are mapping in? We are mapping in iSpices. So iSpices dot map spice. So it's map inside the, now it's map every single element which has setosa to 0 and versicolor to 1 and Virginia. As you can see, this is 0 0 0 and 1 1, and it will show 2 after that. And second, select the first 4 columns of the data frame and then call it. So now we have to say first 4. This means all the rows and first 4 columns. So to go 0 1 2 3 4, because I log it will go to 4, and then we just say first 4, exact 4. So 1 2 3 4, and then it's printing x, and then we have to select the last label and then call it a y. So it's like -1. It will be like it will start from the last one. So we need only one. So it is here. You can see 0 0, as you can see over 1 here. Now it's showing 2 because it's showing from the end also. So it's there 2 also, like Vernos here. Now it's time to split the data. Now we have to split the data and then train the data. So it's like basically we have created like x label, we have created, and y also. So we have already done that. Now we have just have to import the library train test split, as we have done in previous our assignments. Do the same way, do x train, y train, and then use this function which will be imported from this library. And then just what is test size? Test size 0.20. We have to 20%. Test size should be 20%. So 0.20, and then random state number is equal to 123. So this random numbers 123. So now we have to check the x train, y test, and then all of them. So head is showing the, like as I told you, if we don't write 5, it will also show 5 numbers, first 5 rows. Either we write 5 or not. So it's showing 0 1 2 3 4 5, as you can see here, the 5 rows. And the test, and for the same goes for the train and test per data. Now we have to check the length. So if length is 120 and 30 are here, then we are good to go. So first let's test the train. 120, right, 30, so it's working fine. Next train and data and test data has a equal amount of data, the correct amount of data, say. So there's a like good thing in the Python, in the Colab, that we can import this library and then just directly assign it to the label. So we are doing this import to category. I'm assigning 2 underscore categorical 2 as a categorical, and then one hot train label is equal to categorize y train, and then one hot test label is equal to categorical y test. I've assigned to these values now, these and to these ones as a categorical method using this library, inbuilt library. Now we have to create a sequential model. So sequential model, like first we have to like import Keras. From Keras we have to import models and layer to create it. So like we are creating models equal to models of screen, and it says like we have to first use 100 neurons, it should be 100 neurons, like 100 is neuron, and the activation should be ReLU for the first two layers, so as you said. And the third one says pick the appropriate for the last layer. So as of the last layer, this goes to 0, 1, 2, 3. I picked softmax, that is most relevant to it. Now we have to compile our data. So it's given that we have to use this optimizer, and then you have to use appropriate loss functions. I use categorical because we are using categorical. You just assign these to categorical. So this is the best way to, and then the matrix is equal to accuracy, which is normal. So I use this one to figure cost entropy. And now it's going to, and we are now fitting the data. It's like checking the test accuracy and all of it. So X train one hot label, which is Y train data, and then it's X train, and then how many approaches. So there are 20 of approaches, and the batch size should be 10. So the batch size is 10, and now you can see as we go down, the increasing, the accuracy starts increasing. So increases max over here, I guess. See, max is this. So increases here, 9755. This is the maxed the accuracy. So it's like fitting the data or going through all the density, going again and again. So you have to go 20 times and correct itself. So I guess it's not gonna correct it properly, but it keeps going through 20 times and then gives us this data. Every single time there's a new data, you can see new output, new accuracy output. So now we are just checking our loss accuracy. So our loss accuracy is total accuracy is 9.67, average accuracy of all of these steps. So this is the accuracy we got after doing layers. And now we have to do it again with 10 hidden units, 10 neurons, and then ReLU activation, the same, exact same, just with 10. We used 100, now using 10. And then the same, this is the same compiler method, and the fit we usually have to use it for only 4 approaches. As you can see, before we went to the 900, this how much, there's so much data to go through the whole layers, which gives us more accurate performance because there's enough data to produce enough accuracy. But now when we reduce our data and we use our layers, everything, we use our approaches, it reduces the accuracy of the training set of our model. It reduces the accuracy of our model. So this is reduced to 0.43 on average. This is the average accuracy, which is very low, which is nearly half of it. Because it's all happening. So I can see this is better way to explain it. These are some, now you're seeing why that, because there's number of neurons in our model we're changing the number of neurons, as you can say, from 100 to 10, and the accuracy of model, because of that, it reduced greatly, significantly. You can see it's less than half what we got before. So overfitting also impacts the data accuracy. If you have too many layers and then unnecessary too many layers also impact the data, and because worse when we actually try and test it with unseen data. So that also happens. So this can be managed by removing some of our approaches or reducing size of a batch. This are really managed. But let's see. So we have to do it different. We have to create our different models and just check. So first it's I picked up from there, it's 100 layers, 100 that. It's simple model which are done in the above. So it's given. So what I've changed is we have changed the approaches. So as I've changed the approaches, the accuracy also changed. It's not showing, but as you can see over here, the maximum accuracy is 0.89, as close to we get. But before, when I just have 20 approaches, I have to go 20 times from the layers. 27 times, it used to 9. This is the max it got. But now it's because of that, less approaches, less time, less going through the data decreases also. So that also depends. Approaches also matters. How many times we are going to the epochs, how many times we are going to the whole models. I'm checking the data. Now I have added extra layer. So first is 50 and then 50 and then 150. So I added 150 layers, 150 neurons, 150 neurons in these layers. So this 10 size and 10 approaches. look like all of the data is nearly close to the what accuracy should be because amount of layers it has and amount of approaches. So like this is all because like it has enough data to go through the give us the best accuracy as possible it can because of the data we provided, amount of layers we have provided and all of that stuff. So case is 9.69667 is like comparable to like when we have 20 approaches compared to that. So 9.667 for when we reduce the data drastically, like none, like it's like barely enough. So it decreases the like accuracy also very, but like as you can see because of the approaches, like it keeps going and correcting itself, and this produces the better data at the end with this much accuracy. But still the data which we have provided in the layer is like not enough, as you can see here, like warning, like out of the last, because this is coming because like triggered because like there's very less tracing data with less layers is provided. It's not enough layers to go through and not enough accuracy looking for. So that's it. Thank you. If you have any questions, please comment down below. Peace.